right, here's an example on a quadratic model that we want to create a function. So the following data represents the average maximum and minimum temperatures recorded each month in Raleigh, North Carolina over a 6-month period. The temperature recorded is in degrees. So the highest temperature, the max, is going to be your x values, your domain. So when we entered into our calculator, this is going to be our list 1. And then the lowest temperatures will be your y, and that will go into list 2 of our graphing calculator. So then what we would do is choose our quadratic regression model. And I'm just going to put x equaling our max temp, and then our y will be our minimum temp. So then we enter these into our graphing calculator and we come up with our model. So y equals approximately negative 0.007 x squared plus 2.45 x minus 94.5. And by the way, this how to enter this all into the graphing calculator will be done in a separate video. So now we've created our function, and we're going to go ahead and identify the r squared. So that comes from the graphing calculator. So r squared, our correlation of coefficient, is approximately 0.98, which that is very close to 1. So we want it to be close to 1. So what that tells us is that this data set is close to being a strong quadratic model. If that R value was exactly 1, then the strength would make a perfect quadratic model. Part C says, predict the minimum temperature. So the minimum, remember, was our y values, and our maximum was our x values. And the prediction we want to find is what is the y value when the maximum is 90. So x equals 90 degrees Fahrenheit. What would be the temperature of the minimum? So we would either use our table of values and find that, or we could use our function. So again, I'm just writing down that function again, negative 0.007 x squared plus 2.45x minus 94.5. And what we can do is we can substitute that 90 right in for x. It goes right into here, goes right into there to find y. And then we use our calculator to simplify that. And we get our y to be about 69.3. So to predict the minimum temperature, so if the maximum temperature was 90 degrees, the minimum would be 69.3. This would be the minimum temp on that day. Part D now says, predict the maximum temperature. So remember, the maximum is our x, so our x is our unknown, and our minimum temperature, our y, is 40. So we want to find x, and we know the y we can use our table of values. So if we look at our list with the graphing calculator, we have list 1 and list 2. And if I go into the graphing calculator, I have 68 and 69 as my maximum temps. And then my outputs, 39.73 and 41.223, the minimum temps, are really close, right in between here. This would be 40 to really close of 68.5. So the approximate temperature for the maximum would be about 68.5 degrees when our minimum temp is about 40 degrees.